So hello everyone, myself this is Ramakrishna Kama. So I'm going to present you a project on Medichat, a medical chatbot with multilingual support. So my other team member is like Professor Sainsu. Basically, I'm from the Texas A&M University Commerce. Coming to the presentation of this multi-media chart. So here first I'll like, try to discuss with some of the topics like problems of the existing chatbots, what are the improvements we have done in our chatbot applications, and we have discussed about what is the zero shot learning approach. And coming to the future slides of the presentation, we are trying to discuss about the methodology section of this and experiment section of this, and we are trying to give a demo of how our output will be displayed and a comparison of various models in our project. So coming to the abstract of this our project. So in this like abstract, like we are rapidly evolving domain of AI-driven medical consultations. Linguistic inclusivity is a paramount in our like present generations. So here like patient-doctor interactions are much more plays a vital role in a medical consultations. Here we are using a fine-tuned llama model that is nothing but a large language meta AI. So which is developed by the meta research team, formerly is like a Facebook. So introducing a multilingual generation layer, that is the model generated into universal tool for medical consultation. So I mean to say that like here we are using a one multilingual generation layer that will be helpful to give the like understand the various languages and give the results back in that whatever the language the user has been provided. So along with the model improvements, we have added a self-directed information retrieval method. So where I mean to say that like we will get the information up to date and much more accuracy when compared to other models by using a real-time data from the offline databases as well as information from the internet sources. That's a thing we are going to present. Coming to the problems of chatbot applications. So here basically we have majorly four problems we have to discuss with that. That is nothing but a limited information. Presently, the chatbots which have a like limited information which is not up to the mark. So and I mean to say that, and the next thing is inaccurate information. The second thing is, so sometimes like what chatbots will do is like, suppose if we given a one query and the chat mode maybe like give some other information, because like they also don't have like they don't have like a proper knowledge. I mean, to waste amount of data they will have it. So that maybe leads to give a like inaccurate information for that. So, and the third problem we are facing is chatbot overloaded. Suppose if we like hundreds of users will be asking questions at the same time, maybe they will be confused and they are not able to give a proper results at the time. So that may be the third issue. Finally, like misleading medical advice. In this medical advice, like accuracy is a paramount, because like if a person asks you one query and if a Medichat give like whatever the like medical chatbot has given a answer, sometimes if it is a like a wrong answer, that maybe leads to the deaths of the people also. That may be main concern in the chatbot. So that's so in our chatbot we are like a proposed chatbot will be solving that issues, and we have made like a 5 key improvements in our chatbot. So here we are using a fine-tune with zero shot learning approach for the patient-doctor interactions. That's the first one. And coming to the second one, we are using an integration of multilingual support of llama model, consists of over 200 languages. So that's the second enhancement, like which consists of like so many languages in our model. Third point, we are like introducing a dedication layer for multilingual generation. That's the third point. Fourth, we are using a self-directed information retrieval from the medical databases and online sources. So where like we are getting up-to-date information. So this is like a fourth enhancement we have done that. So in our proposed chatbot, we demonstrate considerable amount of compressing patient inquiries, giving a relatable advice, marks a big progress in a medical llamas. So, and finally, in this fifth enhancement, like we are using a up-to-date cutting-edge technologies like natural language processing and machine learning. So where a chatbot comprehends the user inquiries more thoroughly and responses given to that which are more accurately. So this is a 5 enhancements in our chatbot. We are going to be seen in our future slides. So coming to the related work or literature review. So here we are using a different kind of algorithms to get a bit better accuracy for the better performance of the model. So here we are tried with the BERT model, cross-linguist language model, translation-based approach with the transformation model, zero-shot learning with a laser, and cross-language transfer learning with the XML. So this is some of the models we are trying to apply the various data sets for the models. And in the coming slides, we are trying to use like a NLLB 200, like which is nothing but a no language left behind model, which gonna be using in our model. So here, like in chatbots, plays a vital role in a disease predictions kind of things. So it will be helpful to diagnose the various things by using a various cutting-edge technologies, as we are discussing in the previous slides, by using NLP and machine learning techniques. Here we are mainly discussing about three models, that is nothing but ChatGPT, ChatDoctor, and Medichat. So among all the wins, like Medichat, like which has the highest accuracy, and like ChatGPT and ChatDoctor, like which is less accuracy when compared to our model. Coming to the methodology section, here as I discussed earlier, like the large language model Meta, so which is developed by the Meta AI, so which is various sizes from the ranging from 7 billion to 65 billion. So like apart from that, fine-tuning Llama model which consists of three phases: data augmentation phase, transfer learning phase, and multilingual generation layer phase. During the data augmentation phase, so we have to try to increase the data set by using a various synonyms, replacements, paraphrasing, which have been done that. So in the transfer learning phase, what we will do is we will be trying to train the model so that by using artificially created data sets, that maybe leads to increase the knowledge on a particular domain. During a final phase, like a multilingual generation layer phase, we will be trying to integrate model. And then first of all, we will identify what is a user language, and we just need to, according to the user language, we have to regenerate the response and give it back to the user back. That's the third layer in this multilingual. Coming to the NLLB 200 model. So here in this model, we have using 200 different kind of languages where the user can be choose whatever the queries he wanted, and it will be respond for that queries according to whatever the user has been requested that. It will be trained on the various languages, making it robust for linguistic scenarios. And then fine-tuning Llama model, dedication generation layer, the application of NLLB 200 model, the system is said to becomes a universal acceptable tool for medical consultation. Here, when you observe that, like in a diagram, so user give the input query, then it will be try to understand like what is a language, like then mission translation, tokenization phase happen. That means you say that like it will be divided into subtask, and again the subtask will be like what synonyms, all these things will be done in tokenization phase. Then it will be multilingual LAMs will be done. So, and then like translation phase will be done. Apart from that, in the translation phase, it will be finally going to the post-processing phase. Then finally it will be transferred into the output language. So in the zero-shot learning, the model we are using in our project, it is nothing but like, first of all, we will take a sample of the data from the data set. We will train it. Then we will just modify the data set. Again, we will train it. So it will lead to increasing the efficiency and accuracy of the data. Here are key features: no explicit training examples, utilization of auxiliary informations, and diverse set of applications, which are the key features of the zero-shot learning, widely used in the image recognition, NLP, and scenarios where the large and diverse set of classes will be used. And coming to the approaches of the zero-shot learning approach, we are using attributes-based methods, like the represent classes using predefined attributes for the prediction, and embedded methods like learn a continuous representation of space for both seen and unseen classes. Transfer learning, where the fine-tuning of a predefined task will be done in this phase. Here when coming to see in the image, so where we are using a penguin, penguin, pandas, spiny lamsica, it will be based upon the weight and score, like it will be generate some weight. Then based upon the weight, it will be giving the what are the relevant image, like in the image encoder, you can able to see the panda image according to the highest score. Coming to the multilingual language processing, here when we see that, like in the image, like here we first of all we will collect the data from the various sources like source and the target languages. We assemble the data and we will be gather the data. So in the model configuration, we will be first of all try like whatever the model, like that is nothing but NLLB 200 model. So in this NLB 200 model, we will just try to perform that model. I mean to say, we will just like arrange the model, and then we will be doing some operations kind of thing, so that like the whatever the data which is collected from the previous system, which will be taken that model, and data splitting and fine tuning the source language will be done in the coming part of the part. Then whatever the splitting and fine tuning will be done, the evaluation of source language will be done in that by using like various parameters like F1 scores and various accuracy parameters. In that, like after that, like we are using a cross-lingual adaptation phase, like where we using like in this model fine tuning model data from the target languages. After that, like we have to validate the data and like hyperparameter tuning will be done. Evaluation of target language and deployment will be done. This in this validation phase, what will be done is like we will find the data, validate and test the data according to the input query, and then deployment. What are the model we have done that it will be deployed into our application. Finally, we have to monitor and maintain the all the like whatever the steps we have performed so far, the things. So this is this slide we be explain the same thing what I have explained. So coming to the experiment section, so here in this experiment section, we are using a different kind of machine learning studies and less language models, and their use translation in healthcare. Here we are using like various machine learning algorithms like fine tuning, zero shot learning, and other different kind of algorithms. So in all the kind of algorithms, we are trying to use like a zero shot learning approach. And we are using APIs for the implementation integration of multi-language translation layer. And here we are using a various criteria parameters like rogue 1, rogue 2, rogue healthcare. So from that, like we'll just get a score of 0.90, which is far less. So first of all, we thought that to implement a llama model, but due to the GPU issues like and memory issues, we are trying to go ahead with the zero shot learning approach. And here all these things like we have like, I mean to say, whatever the interface we have it, so that's gonna be the main important, because like the user will be interacting with that interface. That's mean the key point here in this experiment. So I'll just try to here is a like sample output of that. I'll just try to give the demo of that. Yes, here you can able to see the screen of like a demo session where we can able to like search for different kind of language. Suppose here we are selecting English language, and I'm giving a results as have fever. I'm trying to search the results, and it will be getting the results displayed here. It will be taking like 25 to 30 seconds because like the GPU issues, like if we try to increase the GPU, like we'll be getting the results very faster. So here is a like, what is the response for that? Like what I have a fever, so it will be giving that like a response for that. Whatever the actions we have to take, what is the like medications we have to take. So I'm coming to the other different languages, like I will just show you that other language as well. Suppose here I'm taking as in Spanish language. So in the Spanish language, I'm using a Google Translator. So I have like a headache. So I'm just trying to copy that things and just giving that information here. So it will be, first of all, what are the Spanish language will get? It will be tried to convert it into English language, that is a system default language. Then it will be search the results and give it back the results back in the Spanish language. That's I can be able to see that results here. here's the results for that Spanish language. So whatever the language you have given according to that 200 language, they will be take that language, perform the operations, and give it back the results back. So that is overall things. So that is overall thing in this. So here, like it will be taking a, like here in this example, I have taken as a French language. I'm just taking one of the example and will giving the results back that particular thing. So here is a comparison of ChatGPT and Chalk Doctor. So where like how to treat OTTs, like if we give that, like how the ChatGPT will give the results and how Chat Doctor will be respond for that particular query. So here is a comparison of ChatGPT and Medichat, where like ChatGPT give the like small kind of information short summary, where in the case of our model, like it will be giving the more accurate and more information about that particular query. So coming to the results comparison, so from the precision wise, like the Medichat and ChatGPT is almost similar. For the case of like a recall and F1 scores, like so Medichat is like way behind, like I mean, like it is more accurate when compared to ChatGPT, and here you can able to see that results. Coming to the future works and implications, like in this future like works, we are trying to more improve the coming to the user interface, and if we try to increase the GPU server, and we'll just get some faster responses, because like right now it's taking 30 seconds to get the results back. We want to try to improve that things, and our goal is to like implement the most efficient, cost-effective solutions to significantly improve the performance and ensuring the user receives the timely and available responses from the system. That's only the main goal of our system. So, and I like to thankful to my team members and my friends like Srinath and Sai Hachita and Viraj Verma. So, which plays a vital role in this project. And thank you for that opportunity.